Conservation law, in physics, a principle that states that a certain physical property, i.e., a measurable quantity, does not change in the course of time within an isolated physical system. In classical physics, laws of this type govern energy, momentum, angular momentum, mass, and electric charge. In particle physics, other conservation laws apply to properties of subatomic particles that are invariant during interactions. An important function of conservation laws is that they make it possible to predict the macroscopic behavior of a system without having to consider the microscopic details of the course of a physical process or chemical reaction. Conservation of energy implies that energy can be neither created nor destroyed, although it can be changed from one form, mechanical, kinetic, chemical, etc., into another. In an isolated system, the sum of all forms of energy therefore remains constant. For example, a falling body has a constant amount of energy, but the form of the energy changes from potential to kinetic. According to the theory of relativity, energy and mass are equivalent. Thus, the rest mass of a body may be considered a form of potential energy, part of which can be converted into other forms of energy. Conservation of mass implies that matter can be neither created nor destroyed, i.e., processes that change the physical or chemical properties of substances within an isolated system, such as conversion of a liquid to a gas, leave the total mass unchanged. Strictly speaking, mass is not a conserved quantity. However, except in nuclear reactions, the conversion of rest mass into other forms of mass energy is so small that, to a high degree of precision, rest mass may be thought of as conserved. Both the laws of conservation of mass and conservation of energy can be combined into one law, the conservation of mass energy. Conservation of linear momentum expresses the fact that a body or system of bodies in motion retains its total momentum, the product of mass and vector velocity, unless an external force is applied to it. In an isolated system, such as the universe, there are no external forces, so momentum is always conserved. Because momentum is conserved, its components in any direction will also be conserved. Application of the law of conservation of momentum is important in the solution of collision problems. The operation of rockets exemplifies the conservation of momentum. The increased forward momentum of the rocket is equal but opposite in sign to the momentum of the ejected exhaust gases. Conservation of angular momentum of rotating bodies is analogous to the conservation of linear momentum. Angular momentum is a vector quantity whose conservation expresses the law that a body or system that is rotating continues to rotate at the same rate unless a twisting force, called a torque, is applied to it. The angular momentum of each bit of matter consists of the product of its mass, its distance from the axis of rotation, and the component of its velocity perpendicular to the line from the axis. Conservation of charge states that the total amount of electric charge in a system does not change with time. At a subatomic level, charged particles can be created, but always in pairs with equal positive and negative charge so that the total amount of charge always remains constant. In particle physics, other conservation laws apply to certain properties of nuclear particles, such as baryon number, lepton number, and strangeness. Such laws apply in addition to those of mass, energy, and momentum encountered in everyday life and may be thought of as analogous to the conservation of electric charge. See also symmetry. The laws of conservation of energy, momentum, and angular momentum are all derived from classical mechanics. Nevertheless, all remain true in quantum mechanics and relativistic mechanics, which have replaced classical mechanics as the most fundamental of all laws. In the deepest sense, the three conservation laws express the facts, respectively, that physics does not change with passing time, with displacement in space, or with rotation in space.